Station 5 of your Evidence for Evolution lab. Here you're going to be looking at how evolutionary scientists can further analyze DNA by using a process called DNA gel electrophoresis. Again, if this is a new term for you, please go to your evolution lab mini glossary at the beginning of your lab packet and look for those key terms that are necessary for you to get an understanding of this process. What you're going to be doing in this station is go ahead and please read, mark, and analyze the text that's up here at the top. It gives you a great kind of introductory understanding of what gel electrophoresis is. If you don't read this, you're really going to struggle through this station. So please make sure you pay attention to this up here. Don't skip through it. The next thing you're going to do is go ahead and go to this URL. It should be open at the laptop that's at your lab station already. But if it's not, go ahead and enter that URL in there, and you should pull up this screen right here. And what this is going to do is it's going to walk you through the different steps of gel electrophoresis, and it is going to tell you the importance of each of those steps. It doesn't necessarily, the questions don't go necessarily in order with the simulation, and they definitely don't stand out word for word. So make sure that you pre-read the questions, please. So go ahead and pre-read the questions and look for keywords and ideas. So what does gel electrophoresis use to separate DNA fragments? So we're looking for an object that is used to separate DNA fragments. It's not going to come out and tell you. You're going to have to look into it a little bit more. To use this simulation, you just follow the arrows that are down here and work through it. Make sure that you are reading the things in blue. Those are where you're going to find most of your answers. Notice that you can do things like turn the power supply on and actually run through the whole process of gel electrophoresis. So step number 1 of this station is going to be answering questions 1 through 6 using this animation. The next step is going to be actually analyzing a electrophoresis gel of deer species. So here's the gel, and you can see that the DNA segments are all separated out. You're going to analyze those and identify which of these deer species, 2, 3, or 4, is most closely related to species 1. As you might recall from our amino acid station, if you've already been there, those organisms that have the most similarities are going to be the most closely related. So down here, you're going to explain to me which species you believed was the most closely related, and tell me why in a very detailed answer using keywords and ideas from your mini glossary and from other things that we've talked about throughout the year. And then down here it says develop a hypothesis that can explain how the 3 different deer species might have evolved. So here you need to talk about things like natural selection. You maybe want to talk about sexual selection, where deer species choosing who they mated with. I don't know. Could it be because of this huge volcanic eruption that separated these 2 deer populations and caused them to evolve separately from one another? Those are the types of things that I would like for you to try to develop for me. Be creative in your thoughts, and if you're giving me detailed and thoughtful answers, you will not be wrong here. Okay? Make sure that all of our answers are completely answered, they're detailed, and using key terms and ideas from this unit in this section.